Hello children, today we are going to discuss refraction and dispersion of light. Children, first what is refraction? What happens children when the light enters from the rare medium to the denser medium, it bends, okay? Or the bending of light when it passes from one medium to another is called refraction. Like just we see, this is air and this is like solid glass, okay? So when the light ray passes from rare medium, like this light ray is coming from rarer medium, this medium is called rarer, and this is what? Denser. Because the particles are very close in the glass and the particles are far apart. And children, we draw normal. Where the ray fall, this ray is called incident ray, and where this ray fall, that point, there we draw normal. Okay? And this ray, when passes from rarer medium to the denser, it bends towards the normal. And children, when this ray going out from the denser medium to the rare medium, it moves away from the normal. So it is clear, these rays, they do not follow the same path. Their speed, the change of speed takes place. Their speed is most in like air and then less in water and least in solids. Okay. So we say optically rarer medium to the optically denser medium. When ray moves from optically rarer to denser, it bends towards the normal, and from denser to rarer, away from the normal. Now what are the effects of this refraction? Children, real and we are going to discuss this. First effect is what? Real and apparent depth. Real and apparent. First, what is real? All you know. What is the real depth? Real means like actual, and apparent means which seems. So we are taking the example of swimming pool. Okay. This is the real depth of the swimming pool. But when we see from outside, like we are seeing from here, what happened? The rays, this is the real depth, suppose D. The rays which are coming, and this medium is what? This is, water is denser than the air. Okay. So it will move away. It will move away or bend away. It seems if we continue these two rays which are reaching to our eyes, okay, if we continue this, it seems they are coming from this point. Okay, so we do not see this real depth. What we see? This apparent depth. So D1 is what? Apparent depth. So we cannot, from outside, we cannot see the real depth. Why? Because of this refraction. Same thing happens when we keep the pencil obliquely in excuse me children, the apparent bending of a pencil like you had done in the class. Okay. Now second, refraction by I am going to tell you refraction by glass slab. Glass slab. This is glass slab. What is glass slab? It's made of solid glass and two sides are parallel to each other. What happened in this? When the ray of light falls, incident ray, okay, it bends towards the normal and the speed is same in the glass. when we see it from the outside, okay, suppose this ray when it comes out, or we say this is incident ray, this is refracted ray, and this is the ray which will come out. It will bend away from the normal because it is coming from denser to the rarer. Children, so we are getting this incident ray in the form of emergent ray, which is coming out from the glass slab. But if we trace this, the path of incident ray, it has to move like this. But it is shifted from here to here. Okay. But both are parallel to each other. So in glass slab, the shifting has taken place, but they are parallel to each other. Why? Because the opposite sides are parallel to each other. Okay. This means that the light ray passing through the glass slab is displaced, but its direction is not changed. Direction you are seeing the same. This is because the two opposite sides of the glass slabs are parallel. Now we are coming to the refraction in prism. Okay, it's like pyramid, a piece of glass. Okay, angular, it is angular. What happened when the light ray will pass through the prism? When it passes here, okay, this is what? Incident ray. We are going to draw what? Normal. It will bend toward the normal, and then again normal. We have drawn. It will move away from the normal. Okay, so you are seeing this ray, it's like this is incident ray, this is a refracted ray, and this is emergent ray. You are seeing incident ray is not going straight. Okay, it is not going straight due to angle and the medium. It is emergent ray, it is shifted like this. How much it has shifted? Like in the glass slab we have seen, it has not changed the direction, only it was displaced. Okay, they were parallel, but here we are seeing it has changed the direction also. So if we trace this, how much it deviates from its path? Actual path, so it has to be this, but it is deviated from its path. If we take this back, so we are seeing this much it is deviated, and this is called angle of deviation. Angle of deviation. Now children, what is dispersion? It is related with this deviation, angle of deviation, dispersion. Children, when white ray, or we say sunlight, passes through the prism, okay, when it passes through the prism, it is split into 7 colors. 1, 2, 3, 4, 5, 6 and 7. And this we get on screen, and this band of 7 color is called what? Spectrum. And this phenomena is called dispersion. Okay, why this happen? Children, as we had discussed angle of deviation, so these colors, Isaac Newton, he had brought in a notice that white light of sun is made of 7 color, and these colors are violet, indigo, blue, green, red, blue, green, yellow, orange and red. But why did it split? The reason behind this is the reason for dispersion is that a transparent medium like prism bends different colors of light by different amount. The deviation is maximum for violet and minimum for red. Okay, that is why we get red here and violet here. Okay. So this phenomena is what? Dispersion, and the band of 7 color we get on screen is called what? Spectrum. Now we are going to discuss about lenses. In your course there are two type of lenses. Two types of lenses. One is convex. One is convex, other is concave. Okay. This lens is called converging lens and this lens is called diverging lens. Converging lens and this is what? Diverging. Other name is what? Convex and convex. First we are going to discuss about the different part of these lenses. Like this point is called optical center and the line passing through this optical center is called principal axis. Principal axis. Children, this principal axis, the line joining the centers of the two sphere. Like this is made of one sphere, this is made of one sphere. Okay. So center of this sphere is this side and center of this sphere is this side. Okay. Same way of this lens also. So C1, C2 and this is the radius. And children, between O and C the point is called focus and the length of this principal axis, the distance between focus and optical center is called focal length. Now I am going to tell you about converging and diverging lens and focus. First, converging lens. Children, why do we call it converging? This different terms I have told you. This is principal axis and this is optical center. How the rays are passing. Very important question, how the rays are passing. Suppose any ray, we take only two rays. Okay, one which is coming parallelly. Okay, after like it is coming parallelly to the principal axis, after passing this denser medium, it will bend and will pass from focus. Okay, pass from focus. So in this lens, all parallel rays which are coming parallelly to the principal axis, after passing this convex lens, they bend towards the focus. Okay, so that is why we call it converging lens. Now, second ray, we take, as I told you, two rays. One ray pass from the optical center when we observe any object. So one ray we take which is running parallelly to the principal axis. Other ray we take that it is passing from the optical center. Okay, and this ray, children, neither bend, nothing happen. It does not deviate. Like it is coming from rarer medium to the denser medium, but it does not deviate. Deviation is very little, but it is negligible. So we say it does not deviate and it passes straight. And third, like one ray which is coming from the focus. As I told you, there are two focus, two center. This is C2, C1 and this is F1, F2. Okay, when the rays are coming parallel from this side, they merge in this focus. But if ray is coming to this focus, it will move parallel to the principal axis. So these things you need to know very clearly. Now we are going to see how the images are formed when in the convex lens, when the objects are placed at different position. So first we are taking object very far off, means like sun when it is at infinity. ठीक है? We call it also magnifying glass. We also call it magnifying glass. Children, when the rays, we are going to draw it like this in the center. ठीक है? This is O, optical center. Of the rays which are coming from very far, means infinity. Object is at infinity. So first ray, as I told you, which is coming, it will directly go to the pass through the optical center without any deviation. And it is coming from very far, so it will pass from this focus. Okay. Coming from the focus, and then it will run parallel to this principal axis. Run parallel to this parallel axis, and the image will form. What kind of image you are seeing? Suppose we are seeing sun. So the size is very small. Very small. Where this is the size. Nature, it is real. Inverted. Real images are always inverted. Position, where it is formed? At focus. So children, these four things you are supposed to write down. Now our second like position is when the object is placed opposite of this. Like object is at focus. Object is at focus. Now I am going to make it small. Object is at focus. Okay. What will happen? First ray parallel to the principal axis. It will pass through the where it will this focus. First ray will pass through the focus. Second, from optical center, you are seeing both the arms, they are diverging, means the image would be formed at infinity, opposite of that infinity. Okay, at infinity, very big. Magnified means very large. Real and inverted, because this side it is forming real and inverted. Now our next position is when the object is at center or 2F. Passing through the optical center, this is F, this is C, and also we write it 2Fy because it's a double of F. First ray, same, parallel, will pass from focus. Second ray, directly will go to the optical center, and children, you know that it will form where C. C2, or we say 2F. Okay. You see the images. This is A and B. This is A and B dash. A dash. This is image. Image, when you observe, you will find this image is same size, real, inverted, real inverted, and it forms at 2F or C. Okay. Now next is when object is placed at between F and O. This is F and this is O. Okay. What happened? First ray will pass from focus. Okay. Second ray will pass from this, and we will find these two rays, when we extend them, they are not going to meet anywhere. It seems they are coming from the back side. Okay, it seems they are coming from these rays. The source is at the back. When we are going to meet them, we will find that they are coming from this point. And when this is image, this is A and B, A dash and B dash. What kind of image is formed? The image is virtual because it is coming from same side. Virtual images are always erect. Size, just you see, larger than the object, larger than the object, and position the same side where the object is placed. Children, this is what other words we can say. This is magnifying glass. When you see the letters or words, you find them enlarged. So this is the way. Okay. Now next position, last position, we say when the object is between F and 2F, what will happen? The image will form other side beyond 2F. Okay, it is going to shift. So this way the images are going to form. I am going to draw this. Okay. When this is F and 2F. First ray, focus. Second ray. Okay, we are going to meet these two. So where it is formed? Beyond 2F. Larger than the size. Okay. And next, concave lens. Concave lens. Concave lens. Concave lens. In concave lens, always the image is formed, because it is at first I am going to tell you, this is a diverging lens. This is optical center. Principal axis is passing. The parallel rays which are moving parallelly to the principal axis, after passing this lens, they diverge. Okay, they diverge. And we see, when we trace where is the source, we will see they are coming from focus. All these rays, they are coming from focus. So that is why we call this what? Diverging lens. That is why we call it diverging lens. So in diverging lens, always the rays falling on a convex lens after refraction always diverge. Therefore, no matter wherever is the object, in any position, we get only, I am going to first draw, then I am going to tell you. Okay, this is object, okay, whatever is the size, and what happened, this will go and diverge, okay. And second ray, as I told you, we pass from the this, it also like going straight. When we bring it back, where these two rays are meeting, where the image formed, where the two rays are meeting. So here we find these two rays, here they are not going to meet because diverging. So back side, it seems it is coming from focus, okay. So here when these two rays are meeting, we see the image is formed. This image is very small, very small. So no matter where the object is kept, a diverging lens always form a virtual image. The image is virtual, smaller in size, erect, smaller in size, smaller in size. It is formed between the optical center position, between optical center and focus. Okay, the same side the lens as the object. So that's all, children. Thank you.